So something pretty big just happened in the world of AI and robotics, something that could actually change how we interact with machines in the next few years. The AI world just got a wake-up call from one of its founders. Yann LeCun, a godfather of AI, just declared he's not so interested in LLMs anymore. This isn't just a bold statement. He's challenging the entire foundation of current AI development. Yann LeCun, a titan in AI, just revealed how current LLMs fall short and introduced his groundbreaking JEPPA architecture, learning like a baby, not just from text. Get ready to discover why text-only AI is not the path to true intelligence, and what revolutionary new approach could actually get us there. So, for a figure LeCun's stature, someone with decades of experience at the absolute forefront of AI research, to say something like this, it makes you stop and think. Is he onto something? Is he right? When asked about the most exciting AI developments of the past year, LeCun's reply was direct. Too many to count, but I tell you one thing which may surprise a few of you. I'm not so interested in LLMs anymore. He explained that, in his view, LLMs have reached a point where they are largely in the hands of industry product people. Their improvements are mostly happening at the margin through things like simply adding more data, more compute, or generating synthetic data. For LeCun, the truly interesting fundamental questions in AI lie elsewhere. He's now focused on 4 key areas. 1. How do you get machines to understand the physical world? A point Jensen Huang also emphasized in his GTC keynote. 2. How do you get them to have persistent memory? Interestingly, LeCun noted this is a topic not many people are talking about. 3. How do you get them to reason? 4. How do you get them to plan? While he acknowledges there are efforts to make LLMs reason, LeCun believes it's a very simplistic way of approaching reasoning. He's looking for better ways of doing this. He's genuinely excited about the kind of cutting-edge research that might seem obscure in an academic paper today, but could also become a major breakthrough in 5 years down the line. This brings us to one of LeCun's core arguments, the concept of world models and why AI training solely on text is simply not enough for true artificial general intelligence, or AGI. He contends the non-token prediction paradigm, while incredibly effective for real language tasks, utterly fails when it comes to understanding and interacting with real physical world. LeCun explains, what is a world model? World model is we all have world models in our mind. This is what allows us to manipulate thoughts essentially. He uses a simple, relatable example, pushing a bottle. You know that if I push on this bottle here from the top, it's probably going to flip. But if I push on it at the bottom, it's going to slide. And you know if I press on it too hard, it might pop. He points out that humans acquire these fundamental physical world models within the first few months of life. These intuitive understandings are crucial for us to navigate and interact with reality. And crucially, LeCun argues that dealing with the real world is much more difficult than to deal with language. Therefore, the AI architectures needed to truly deal with the physical world must be completely different from the ones that we deal with at the moment, which are primarily designed to predict tokens. So, why are tokens the wrong way to represent the physical world? Tokens are discrete, he states. In a typical LLM, you're working with a finite set of possibilities, maybe around 100,000 tokens. When you train a system to predict the next token, it's essentially predicting a probability distribution across the limited dictionary. However, in the real world, unlike text, is high-dimensional and continuous. Every attempt to get AI systems to understand the world or build mental models by training them to predict videos at the pixel level has basically failed. He even noted that learning good representations of images by reconstructing them for corrupted versions hasn't worked as well as alternative methods. LeCun illustrates this with a simple video example. If an AI sees a video in a room, then the camera pans and stops, and you ask it to predict the continuation. It might guess it's a room and there's people sitting. But, he emphasizes, there's no way it can predict what every single one of you looks like, right? That's completely unpredictable. There's a lot of things in this world that are just not predictable, he clarifies. Training an AI to predict every single pixel means it wastes immense computational resources trying to invent details it cannot possibly know. LeCun reveals that he's been working on this problem for 2 decades. And his conclusion is firm. Self-supervised learning by predicting video only works at a representation level, not at a pixel-by-pixel level. This critical distinction means these effective architectures are not generative the way the current LLMs are. So, if predicting the next token in a transformer architecture isn't the solution for understanding the physical world, what is? LeCun argues that inherent, implicit understanding and reasoning we take for granted when interacting with the physical world simply cannot be translated into a next token prediction model. I've actually discussed similar research in a previous video, where studies on models like Sora suggest they might be mimicking the physical world rather than truly understanding or predicting it. If you want to dive deeper to that, check out my video. But if current methods don't work, what is LeCun's proposed solution? This is where his famous JEPPA architecture comes into play, and excitingly, he mentioned that version 2 is coming very soon, with incredibly promising results. LeCun agrees with NVIDIA CEO Jensen Huang that AI systems ultimately need the ability to reason. However, he strongly disagrees that augmenting current LLMs with reasoning abilities is the right path. It's not the way, he asserts. He believes that human reasoning occurs in an abstract mental state that is entirely separate from language. You don't like kicking the tokens out. You want to be reasoning in your latent space and not abstract space, right? He offers a brilliant example. If I tell you, you know, imagine a cube floating in front of you, and now rotate that cube by 90 degrees around a vertical axis. Okay, so you can do this mentally. It has nothing to do with language. You know, a cat could do this. Cats, he notes, plan complex trajectories for jumps that are far more sophisticated than simple verbal commands, and they do that without language or token space. This, LeCun states, is the challenge of the next few years. So yes, there is a new model coming. It's called JEPPA, Joint Embedding Predictive Architectures. My colleagues and I have kind of put out a bunch of papers on this over the last few years, LeCun explained. JEPPA models are designed to learn abstract representations of the world. They can then manipulate those representations, reason about them, and produce sequences of actions to achieve specific goals. I think that's the future, he declared, referencing a detailed paper he wrote on the concept about 3 years ago. LeCun confirmed that they're getting close to a version 2 of JEPPA. He highlighted that the first version, trained on short 16-frame videos, can predict the representation of a full video from a partially masked one. The system can even tell you, in restricted cases, whether a particular video depicts something physically possible or not. It does this by measuring its prediction error. If something truly strange happens, like an object disappearing or defying physics, the system's prediction error will spike, indicating the anomaly. LeCun then drew a fascinating parallel to human cognition, System 1 and System 2 thinking. System 1 is intuitive, automatic, and subconscious, tasks you accomplish without much effort, like an experienced driver. System 2 thinking is deliberate, focused, and requires conscious planning, like a new driver navigating unfamiliar, complex traffic. This idea that you start by using your world model that you're able to accomplish a task, even a task you've never encountered before. Zero shot, right? You don't have to be trained to solve that task. On the basis of your understanding of the world and your planning abilities, that's what's missing in current systems. He explains that current LLMs primarily operate in System 1. They're reactive and subconscious, while they are inching their way towards System 2. LeCun firmly believes that a fundamentally different architecture is ultimately needed for System 2 reasoning. So, what are your thoughts on Yann LeCun's bold claims? Do you think he's identified the true path to AGI, or are LLMs still the dominant force for the foreseeable future? Let me know your perspective in the comments below. If this deep dive into the bleeding edge of AI research fascinated you, please give this video a thumbs up. And don't forget to subscribe to our channel and hit that notification bell so you don't miss future explorations of artificial intelligence and its incredible potential.